Hey there. So this is our second lesson out of four. For question number one, whenever I see a table and I need to get the slope or rate of change, make sure on the Desmos, so you are using the Desmos Texas Star version because it's going to have different functionalities. This is what you'll have for Star. But I push the table button and I need to enter two of the ordered pairs or two values from the table into the table on Desmos. Then I'm going to type in y1 approximation mx1 plus b. This is going to match my equation to the table, and it will graph the line, and it will give me the slope and y-intercept. If I look right here, I have a negative 0.27 repeated, but my answer choices are in fractions. I know, though, that I can go ahead and cross out my two positive answer choices. I do not need those. They are not correct. I guess I have to click it twice. There we go. So next I'm going to, in Desmos, put these two fractions in to see which one would be 0.2727. Try out negative 3 over 11. And look, it is correct. Also, this one obviously would have a whole number because the numerator is bigger. Going on to number 2. It's the same process as the first one. So I'm going to click on the plus add item using star Desmos. And I'm going to put in two values from the table. So when x is 1, y is 15.25. When x is 3, y is 17.75. And right below, I'm going to put y1 approximation mx1 plus b. And I see that my rate, slope, average rate of change is going to be 1.25. On number 3, on this one, I actually prefer to use the actual graph given. So I would want to see for every one deposit, how much is in my savings account. So here I look at for every one on my X value. So per deposit, for every one, it's $300.
Teachers, please take attendance. Infinity Middle School.
Gotta take attendance.
Please take attendance at this time.
I'm going to go ahead and put my scratch pad away. And I can see that for every one deposit, I save $300, or I have $300. All right, for number 4, when I have two ordered pairs on a graph, I can either find them or they're provided for me. I can still use that same method. I'm going to use the table method on Desmos. I'm going to enter my two ordered pairs, put y1 approximation mx1 plus b. And here I have the rate of change, or slope, m, is going to be negative 0.2. For systems of equations, I want to always just start by entering both of the equations they give you. And if you are on the correct Desmos, which we all should be, I would notice, though, that the second equation will not graph. So I need to either isolate the x, like in right here where it has x equals, right there, or I need to isolate the y. In this case, I feel like I'm going to just go ahead and isolate my y. So I'll put in y equals mx plus b. So first I'm going to do the exciting move. I'm going to move my 3x from the left to the right. I highlighted it, Control X. it was a positive, so I have to do the opposite. So instead of a positive, I put negative 3x. So I can move things by making them the opposite or divide by coefficients. Here I have a positive 5. And the great divide says I have to divide everything by the coefficient. So I moved my positive 3x to the right by making it negative. I divided by the coefficient of y. Now the point where both the purple and the black line meet would be the solution, xy. So this is one where it's not just one solution, not just your x value, but it is a systems of equations. So they want both solutions, x and y. Solution x and y as a system. For the next one, this is another systems one, but this time they only want the y coordinate. I don't know if there's a, I don't really see, I guess I can do it by scratch pad to just make sure it's highlighted. The y coordinate is what they want for the systems. So next I'm going to put in both of the equations, negative 3x plus 2y equals 6, 4x minus y equals 2. Both of them are going to give me an error. Here I see a negative y, and I'm just going to right away put in the coefficient, which is 1. If there's one y, it would be 1. Now I'm going to do my exciting move, moving a negative 3x from one side to the other. But if it was a negative, it needs to become a positive. I have to have the opposite operation. Then I divide by the coefficient of y, control X, highlight my right side, divide, and paste. Then exciting move, opposite. Divide by everything by the same coefficient. Here I have a positive 4x. I'm going to go ahead and move it from one side to the other. But instead of a positive 4x, it becomes negative. Now I'm going to do my great divide. I'm going to divide everything by the coefficient of y. Now I have both graphed, and I can see that my x coordinate is 2. My y coordinate is 6. Here I have a drag and drop answer. So the rate of change of y respect to x is blank. It looks like positive or negative, and then dollars per year. I can use my table method where I'm going to input 2 of the ordered pairs into the table. I cannot put the commas for my ordered pair. So if it's 8,860, I have to put that in just as straight numbers, no commas included. Y1 approximation mx1 plus b. And I see that I have a negative rate that is $1,600. So it looks like the value is decreasing each year. For number 8, we have a swimming pool that holds 15,360 gallons of water. And every 3 to 5 years, the swimming pool must be drained for maintenance. So that's just kind of telling a story. Submarine water pump can drain the pool at an average rate of 1,800 gallons per hour. So this one, I have a starting value of 15,360 gallons. Forgot my equal sign. And to drain is to take away 1,800 gallons per hour. So this would be my correct equation where I'm starting off with a full pool and I am going to drain or take away a certain amount each hour, per hour. The per or each is always where we are going to isolate or find our x. Number 9 is going to be a systems of equation writing, where I have a total cost and a total copies. So I have two totals that will be on the end of the equal sign. And the cost of the black and white is 8 cents. The cost of the color is 15. So this all needs to be attached to cost. So the cost of these two will add up to $6. So I need to have the cost of black and white, where B is black and white, so 0.8 for B, and then 15 cents for C, $6. Whereas the black and white copies and the color combined is going to be 68. So we're mainly trying to make sure we match. Money needs to all go with money, and then the items need to all go with the items. We also really want to make sure that we know that B is for black and white, 0.8, 0.08, and C is for color copies, 15. Last one. This is a kind of a tough one. This is probably going to be one of the tougher. We have two systems of equations, 8x minus 4y equals negative 16. And we have 3x plus 15y equals negative 6. For both of these, I need to do my exciting move. I'm going to move the 8x from one side to the other. But instead of being positive, I'm going to have it be negative. Same with this. Let's go ahead and move the 3x from positive 3x on one side to negative 3x on the other. I'm going to great divide. So take the coefficient of y and divide the right-hand side by the coefficient. Take the coefficient of y and divide the right-hand side with the coefficient. I've gotten pretty fast at this. Now I can see, oh, okay, this picture looks like that picture. All right, that's all the questions, and I hope you did a great job. You're going to do amazing on the star. And great job.